Alright, we're doing some shell practice, and it says given the region contained by x equals 2y minus y squared and x equals 0, find the volume when the region is rotated around the x-axis. Okay. So keeping in mind, if we go around the x-axis, the formula would be 2 pi from our endpoints a and b of radius times height in terms of y, so it'll be dy. So if we go around the x-axis, we are in dy. Okay. So let's try and draw this out. Might not be as easy considering the way it's written, but let's see here. So xy graph, so 1, 2, 3, 4, 5, oh, sorry. Alright, so my xy graph, I've got x equals 0 and I've got x-axis. So I'm going to go around the x-axis. Not quite sure I'm there yet. But x-axis. And I'm contained by x equals 0. So everything's going to be in the first quadrant, I believe. So let's see here. The function here is x equals 2y minus y squared. Now that's a quadratic, but it's in terms of x equals instead of y equals. So let's see here. If we try to find the intercepts, we can set it equal to 0. So x equals 0. And we'll factor this other thing. We'll pull out a y. So we'll have y times 2 minus y. So it looks like when x is 0, we have y equals 0 and y equals 2. So we have 2 points on the y-axis, that's where x is 0, and I believe this thing goes out to, let's see, I'm not exactly sure how far out it goes. The version would be out to, I believe it's 1. So when y is 1, we will get x being 1. Yeah. It looks like a parabola on its side like this. And this is the region that we want. So when we rotate it, we'll get a similar region in the fourth quadrant when we rotate it. Horrible at drawing I am. Come on, Mr. Eraser. Alright, let's see. Let's try and make it a little bit bumpier. There we go. Not quite great, but it'll look like this when we rotate it. So let's figure out all the things we need, and remember we want them in terms of y. So the volume will be 2 pi from a to b, and it looks like in terms of y, that would be from 0 to 2. The radius will be y, and that is going out from the x-axis. So this way would be the radius. And then the actual height would be the actual function here, which would be 2y minus y squared. That would be coming off the y-axis out. So we've got the radius and we've got the height, and everything is in terms of dy. So the integral we're going to look at is 2 pi times the bounds 0 to 2, and then integrate y times 2y minus y squared dy. So let's clean that up real quick. 2 pi from 0 to 2, so that'll be 2y squared minus y cubed dy. Now we're ready to integrate. So let's see here. 2 pi, we'll have 2/3 y cubed minus 1/4 y to the 4th, and that'll be from 0 to 2. So let's make sure. I think that's good. So then we let y equal 2. So we'll have 2 pi, and then we will have, plug with 2 in, we'll have 16/3 minus 4, I believe, and then when we let y equal 0, it looks like we get 2 pi times 0, so this last part goes away. So that's 2 pi, and I need to make a common denominator between 16 thirds and 4. So it'll be 16 thirds minus 12 thirds. So that's 4 thirds. So in the end, it looks like I get 8 pi over 3 when I combine things. Alright, I'll check the back of the book, and you'll either see me again if it needs to be fixed, or you won't if it's good.